Alright, good day. I am Engineer Tolentino. I am going to discuss now, the ninth lesson of the course, Bernoullis differential equation. This is a first order differential equation, another first order differential equation. I am Romeo Tolentino from NU Manila, Philippines. Okay, let me define what is a first order differential equation. Now, a first-order differential equation of the form dy dx plus yp of x equals y to the n q of x is called the Bernoullis equation in y. Notice that if without this y to the n there, okay, without this y to the n there, okay, this dE is just linear. So that means if n is 0 here, the differential equation is linear. Okay, in order to solve this differential equation, okay, this is similar to a solution of a linear differential equation. Alright, divide both sides by y to the n. So if you divide both sides by y to the n, okay, you will have what? Okay, if you divide both sides by y to the n here, so divide both sides, okay, divide both sides by 1 over y to the n. Okay, so this will give you y to the negative n dy dx plus y to the 1 minus n p of x is equal to q of x. Now if you let this transformation, okay, here, if you let this y to the 1 minus n be equal to v, so here v is y raised to 1 minus n, then your dv dx is of course 1 minus n y to the negative n dy dx. Okay, notice that here we can what? We can multiply both sides, multiply the left and the right side of this equation by 1 minus n in order for the term to be similar here. So there is 1 minus n there, and then 1 minus n y to the 1 minus n p of x there, and then 1 minus n q of x there. So observe that this will be what? This will be, alright, dv dx. So this is dv dx there. And then this is just, remember that this is what? This is our v. Okay, and the differential equation will become a linear one. dv dx plus 1 minus n bp of x is equal to 1 minus n u of x. And the solution of this will be what? Will be just linear. So let's have one example. Okay, let's have dy dx plus 3y over x equals x to the fourth y to the cube. Is it linear? Well, obviously, it will take the form of dy dx plus yp of x equals y to the np of x, where your n here is 3. So your n is 3. So what you do is divide. Okay, so what you do is divide. Okay, divide both sides, or just multiply this by multiply that by 1 over y cubed. 1 over y cubed. So this gives you what? Alright, this gives you y raised to the minus 3 dy dx plus 3y to the minus 2 over x is equal to x to the fourth. Okay, now if you let v, alright, the technique here is let this be equal to b. So if you let b is y to the minus 2, then your dv dx is negative 2 y to the negative 3 dy dx. Now all you have to do is to make it similar to this, okay, multiply this by negative 2. So multiply that equation by negative 2. So what happens is you'll get what? You'll get negative 2y to the negative 3 dy dx minus 6y to the negative 2 over x is negative 2x to the fourth. And you notice that this is already what? This is already dv dx. Okay, dv dx. And this is b. So you'll get a linear what? You'll get a linear differential equation dv dx minus 6b over x is negative 2x to the fourth. This is a linear differential equation in b. So the solution is b times integrating factor equals integral of integrating factor times that function negative 2x to the fourth dx plus c. Now what is the integrating factor? You know that this is our p of x there, that negative 6 over x. So you have what? You have integrating factor is e to the negative 6 over x dx. That's e to the negative 6 ln of x. That's e to the ln of x to the negative 6. That's the same as x to the negative 6. And using that what? And using that formula, substitute it here. You have v times the integrating factor is x to the negative 6 is equal to the integral of, again, the integrating factor times this function there, negative 2x to the fourth dx plus c. Further integrating vx to negative 6, you can multiply this as x to negative 6 times x to the fourth, that is negative 2x to negative 2 dx plus c. Further integrating, you have vx to negative 6 is negative 2x, that's negative 2 plus 1, that's negative 1 over negative 1 plus c. Simplifying again, you have vx to negative 6 is 2 over x plus c. And then returning, remember what is our b? Okay, our b is, what is this b? Our b is, remember this one, b is y to the negative 2 there. So you will have to plug it there, and then you get what? Y to the what? Y to the negative 2, x to the negative 6 equals 2 over x. Or of course that can be written as 1 over y squared x to 6 equals 2 over x plus c. This is our, okay, this is our final answer. Okay, this is our final answer. Now another approach to the problem is we can do integrating factors by inspection. Okay, this is the original problem. dy dx plus 3y over x equals x to the fourth y cubed. Then alright, multiply this. Okay, you will have to multiply both sides there by x dx. Okay, x dx. So what happens, this will become simply what? X dy plus 3y dx, and then this is x to the 4 times x, that's x to the 5th y cubed. Okay, there is a special DE, okay, integrating factor, that is the derivative of x to the p y to the q is x to the p minus 1 y to the q minus 1 py dx plus qx dy. Alright, let us write this as 3y dx plus x dy is x to the 4th y cubed dx. You see that this is our what? This is our p, this is our p, and this is our q. So your p is actually what? 3, and your q is actually what? 1. Okay, so okay, we can now use this special formula. Alright, so you will have to multiply both sides by x to the 3 minus 1, subtract p to 1, and then y raised to 1 minus 1, the left and the right. What is this left side here? That is x squared times just a constant. So basically you multiply the left side by x squared, so just multiply the right side by also x squared. Okay, and therefore, okay, based on this formula there, okay, this special formula here is the same as the derivative of x cubed y, and the right side there is x squared times x to the 5 is x to the 7 times y cubed. Now you will have to divide this, okay, you will have to divide this by something that will eliminate what? That will eliminate y here because there is the x, and the only factor is that x cubed y cubed. That's x cubed y cubed. Why is it y cubed? Because it will eliminate that y cubed and y cubed there. Why is it not just x cubed y? Because if it's just x cubed y, there will be y squared there. Remember that y here must be eliminated. So the only possible divisor here is x cubed y cubed. Okay, and further simplifying, okay, this is x to the 7 and x to the 9. Y cubed will cancel out, and this will give you x to the negative 2 dx, while this is x cubed y to the negative 3 derivative of x cubed y. So that's the time that we can integrate right away. The integral of x cubed y negative 3 derivative of x cubed y is x integral of x to the negative 2 dx. And then we can now integrate, that's just add 1, x cubed y to the negative, that's negative 3 plus 1, it's negative 2 over negative 2 is equal to x to the negative 1 over negative 1 plus c. Okay, multiplying this by what? Multiplying this by negative 2, multiply this by negative 2 gives you what? Gives you just x cubed y to the negative 2 is just 2x to the negative 1 plus another constant c1, where c1 is just c times negative 2. And further simplifying, this is 1 over x to the 6y squared equals 2 over x plus c1. So this is our what? This is our general solution. Yeah. Let's have another example. This time we have what? Dx dy plus xy to the 4th is equal to 3 over 5 x to the negative 4 y to the 4th. Alright, will it take the form of this dE? Dx dy plus x p of y equals x to the n p of y. Now remember, the roles of x and y here are reversed, unlike in our previous example. But this time, this is a Bernoulli in x. Okay, this is now a Bernoulli in x with, okay, here, is this comparable? Okay, do we have a dx dy? There, we have a dx dy. Do we have an x? Yes. Do we have a p of y? Yes, that's y to the 4th. Do we have an x to the n? Yes, that's x to the negative 4. And do we have a p of y? Yes, that's 3 over 5. Okay, that's 3 over 5 times y to the 4th. So what do we have to do is, okay, you will have to, okay, to get rid of x to the 4th there, multiply this by x to the 4th. Okay, once you do so, you will have here x to the 4th dx dy plus x times x to the 4th is x to the 5 y to the 4th is equal to 3 over 5 y to the 4th. And then you will have to, okay, you will have to replace this as b. So the transformation is let is b. So if you let what? If you let b is x to the 5, then your dv dy is 5x to the 4th dx dy. There is missing 5 here. So what you do is, okay, you multiply this by what? By 5. So that will be similar to 5x to the 4th dx dy. So you will have what? You will have 5x to the 4th dx dy plus 5x to the 5 y to the 4th is equal to just what? 3 over 5 times 5 is 3y to the 4th. Now remember that this is already what? This is already dv dy, and this x to the 5, remember that is what? That is our b. So our differential equation now becomes what? Becomes dv dy plus 5by to the fourth equals 3y to the fourth. Now this is now a linear differential equation in b. Now, so this is now a linear differential equation in b. That's the same as dv dy, okay, plus v p of y is equal to what? Is equal to p of y. Q of y. So our integrating factor now is what? Our integrating factor now is e to the integral of y to the fourth dy. That's e to the 1 over 5 y to the 5. Okay, so you will have to use this formula now. This is, remember, okay, this is, remember, our integrating factor there, that is if, and then also this is if there. So this is if there. So you have what? You have v e to the 1 over 5th y to the 5th is equal to e to the 1 over 5th y to the 5th times 3y to the 4th dy plus c. And integrating, of course, if you let u is if you let u is y over 1 over 5, right? If you let that u is what? Y to the 5th over 5, then your du is just what? Your du is just y to the 4th dy. So basically this is just e to the u du. Just remove the 3 there. So ve to the 1 over 5 y to the 5 equals 3e to the 1 over 5 y to the 5 plus c. Then, alright, divide both sides by the e to the 1 over 5 y to the 5. You simply have 3 plus c e to the negative 1 over 5 y to the 5. Now you will have to return that b there. So you get what? You get x to the 5 is equal to 3 plus c e to the negative 1 over 5 y to the 5. Alright, this is our general solution now. So this is the end of the discussion. Okay, thank you.